This will be your consolidation video for Unit F, Lesson 3, Solving Problems with y equals mx plus b. All right, our first question asked us to create a diagram to show everything we know about y equals mx plus b. And while me on my own, I probably won't generate as much ideas as all of you would on the board, I'll try to go over some of the key points about y equals mx plus b. Y is your dependent variable. Right? Y depends on x, which is your independent variable. M is your slope, also known as your rate of change. Rate of change. It also comes in the form rise over run. Right? What else do we know about slope? Well, we know from lesson 1 that the same slope means parallel, and negative reciprocal slopes, reciprocal means perpendicular. Perpendicular. Okay? That's a lot of what we know about slope. With the y-intercept, on the other hand, that's your b. This is where your relation starts, right? This is your starting point. In other words, the b gives us a free point on the line. Right, 0b is a point on that line, okay? So what needs to be true for two lines to be parallel and perpendicular? I kind of already said that, right? Parallel is same slope. More specifically, it's also a different y-intercept. Different y-intercept. Because if they have the same slope and the same y-intercept, it's actually the same line. So for example, 3x minus 1 and 3x plus 2 are two parallel lines because they have the same slope, different y-intercept, okay? With perpendicular lines, the slopes must be negative reciprocals. That is a big fancy math word for you change the sign and you flip the fraction. So in other words, if you have a line, 2x plus 1, we're going to flip 2 into a half and make it negative. And then any y-intercept will do. These two lines are going to be perpendicular. If you know the coordinates of 2 points on a line, how can you find its equation? Well, if we know 2 points, right, let's say these are 2 points on the line, we immediately can find the rise and run between those 2 points. Find rise and run. We can find the rise and run between those 2 points. You can do this with a table. You can do this with algebra. You can do this by graphing. In Unit D, maybe B, we saw a few different ways to do this. So we can find the rise and run, and the slope is the rise and run. Rise over run. So we immediately have one of our two parameters. The m is done. From there, we can take the x and y coordinates, take your x and y, and plug them in, right? If we use y equals mx plus b, we now know an x, we know a y, we know an m, and we can solve for b. Right? You can do this on the graph, you could do this in the table, right? If you set up your table, right, and you have your 2 points, you could find the rise and run, go backwards, get the y-intercept. You could do this algebraically. There's many options as to how you find this rise and run and how you solve for b, right? These have a lot of freedom, a lot of different ways you could do this. But that's going to be your process. You're going to somehow find the slope, somehow find the y-intercept, and then put it together. Okay. Question number 4. Give an example of an original line and one that has been shifted up or down. So let's make a line here, and I think I want a negative fraction slope here. So let's start at maybe 5. I've drawn pink here. And maybe let's go down 2 over 3. Right, down 2 over 3, down 2 over 3, and back up this way. So here is our line. If I could draw straight, that's our line, okay? Because this line goes down 2 over 3, its slope is negative 2 over 3. Because it starts at 5, its y-intercept is 5. Now let's look at it, one that's been shifted up or down. So same line, same slope, we're just going to shift it, maybe let's say down 6 units. We're going to start at -1 instead. So our new y-intercept is -1. But other than that, the slope is the same. It's still going to go down 2 over 3, down 2 over 3, down 2 over 3, back up this way. And then we're going to have our new line like this. And so what is its equation? Well, it had the same slope. It just now started at -1. And note here that this down 6, we can see that in the difference between our two equations. All right, number 5. If a line is parallel to the line 3 over 4x plus 1 and goes through -8, -7, what is its equation? And so we have to kind of break down, okay, what does this mean? Well, if a line is parallel, we know that that means same slope. Same slope. So our new line is going to have that same slope, 3 over 4. The only question is, what is the y-intercept? We need to figure that out. Well, that's where we're going to use the other piece of information, that it goes through the point -8, -7. And you can do this a variety of ways. We did a whole couple of lessons on finding the y-intercept given a point in the slope. You could do this with a table. You could do this with algebra. Trying to think of what would make the most sense here. Maybe let's try table. That's one that seems to go well, but people usually forget about. We have a point -8, -7. And we know that every time it rises by 3, it runs by 4. So we're going to go -4, -4. One more time, 0, -1. And so your y-intercept here is -1, completing our line. -3 over 4x minus 1. And that is how to do a few different types of problems by using y = mx + b.